Hello students, today I will discuss about derivative differential calculus. It is lecture 3. This is the theorem. If a function f whose domain is a, b, lower interval a and upper interval b in the interval a, b, f maps from a, b to r is differentiable at the point x equal to c, then fx is continuous at the point C. That is, derivable implies continuity, but the converse is not true. Obviously, C lies between A and B. We have to prove this. Since fx is differentiable at x equals to c, therefore f dash c equal to limit x tends to c fx minus fc divided by x minus c. This is finite. It is a finite value. Finite. Since fx is differentiable, fx is differentiable imply this. Now we have to prove that fx is continuous at x equal to c. To prove this, we can write fx minus fc equal to fx minus fc divided by x minus c into x minus c. This will cancel and it will be equal to fx minus fc. Taking limit on both sides, limit x tends to c fx minus fc. Also take limit here, limit x tends to c fx minus fc divided by x minus c into x minus c. This implies limit x tends to c fx minus limit x tends to c fc. That means fc, because there is no x in fc. fc is constant. So limit of fc will be only fc equal to limit x tends to c fx minus fc divided by x minus c into limit x tends to c x minus c. Because limit of two function fx into gx will be limit of fx into limit of gx, this property. So imply limit x tends to c fx minus fc equal to this equals to this, means f dash c and f dash c, and this equals to direct put x tends to c, so c minus c tends, that equals to 0. Therefore, limit x tends to c fx minus fc equals to 0. This implies limit x tends to c fx equals to fc. So fx is continuous. This is the conditions of continuity. So fx is continuous at x equals to c. Therefore, we can write fx is continuous at x equals to c. So when a function is derivable at a point, then the function is continuous at that point. But the converse is not true. To prove the converse, we have to take an example. Suppose the converse, we have to take an example. Suppose fx equals to modulus x, modulus functions. Modulus x. Modulus x means x when x greater than or equal to 0, or minus x when x less than 0. This is the definitions of modulus x. Then fx is continuous limit x tends to 0 plus right hand limit fx equals to limit x tends to 0 plus fx means modulus x equals to limit x tends to 0 plus fx x tends to 0 plus, that means x is greater than 0. X is greater than 0, the value of modulus x is x this equals to direct put 0. Limit x tends to 0 minus fx, this equals to limit x tends to left hand limit of modulus x tends to 0 minus x when x less than 0. When x less than 0, then the value of mod x is minus x. If you direct put 0 minus 0, that means 0. And f0 equals to modulus 0, that means 0. Therefore, we have limit x tends to 0 plus fx equals to limit x tends to 0 minus fx equals to f0. Therefore, fx is continuous at x equal to 0. Fx is continuous at x equals to 0. So, modulus x is continuous at x equal to 0. Now we have to show that modulus x is not derivable at x equals to 0. To prove this, left hand derivative limit x tends to 0 minus fx minus f0 divided by x minus 0. That means limit x tends to 0 minus fx means modulus x f0 0 modulus 0 0 by x. This equals to limit x tends to 0 minus modulus x by x equals to limit x tends to 0 minus modulus x means minus x because x tends to 0 minus x less than 0, so modulus x is minus x. X cancels, minus 1, this equals to minus 1. And right hand derivative limit x tends to 0 plus fx minus f0 divided by x minus 0. This equals to limit x tends to 0 plus fx means modulus x, f0 means 0 by x. Since x tends to 0 plus, that is x greater than 0, so modulus x equal to x. Limit x tends to 0 plus x by x, cancel 1, so the limit is 1. Therefore, left hand derivative not equals to right hand derivative. Therefore, modulus x is not derivable at x equal to 0, although it is continuous. So derivative implies continuity, but the converse is not true. Derivative implies continuity, but the converse is not true. Now, example of some derivative, we have to find out ddx of log of mod x. ddx of log of mod x equal to mod x. We know modulus x means x when x greater than or equals to 0 minus x when x less than 0. So we take two cases. When case 1, when x greater than 0. Obviously here we have to take here modulo ddx of log of mod x. X cannot be equal to 0 because log 0 is undefined. So we take here x greater than 0. For x equals to 0, x is not equal to 0, we have to take, because log 0 is undefined. So when x greater than 0, then mod x means x, then ddx of log mod x equals to ddx of log x equal to 1 by x. Case 2, when x less than 0, then minus x is positive. That is modulus x is the positive value. Positive value means minus x. X negative, then minus x positive. Suppose x minus 2, then minus x is 2. In this case, ddx of log of modulus x equals to ddx of log of minus x. This equals to 1 by minus x into chain rule. Derivative of minus x means minus 1. This equals to 1 by x. So whether x greater than 0 or x less than 0, derivative is always 1 by x. Therefore, we have found ddx of log of modulus x equals to 1 by x. ddx of log of modulus x equals to 1 by x. Now ddx of number 2, ddx of sine inverse, very easy example, sine inverse e power x, ddx of sine of e power x. So we know ddx of sine inverse x equal to 1 by root over 1 minus x square. This is formula. Here composite functions. One function is inverse function, sine inverse first function, and second function is exponential functions. We know ddx of f of gx. In lecture 2, I have given this formula, ddx of f of gx, that means dd gx of f of gx into g dash x. So we have to first apply the derivative of sine inverse. Sine inverse means 1 by root over 1 minus sine inverse x. X means e power x here. There x, here e power x. So we take instead of x, we have to take e power x. So sine inverse, this means 1 by root over 1 minus e power x whole square. Now g dash x. Gx means e power x. So ddx of e power x. So it will be 1 minus e power 2x into derivative of e power x is e power x. This equals to e power x by root over 1 minus e power 2x. It is derivative of sine inverse e power x. Simple example 3, ddx of log x. There are two functions. First is log function, then is the log. So first we have to take this log. Derivative of log x 1 by x. Then derivative of log x, 1 by log x. 1 by log x into, if we take this z, log x as z, then it will be log z. 1 by z into derivative of z, chain rule, into ddx of log x. 1 by log x, ddx of log x means 1 by x. This is 1 by x log x. X log x. Now, take another example. If y equal to log of x, then ddx of y, first take this log. Log x means 1 by x. For this log, 1 by this, 1 by log of x. Now, second, derivative of this into ddx of log x. Then this will be log x into this log, derivative of log x, 1 by log x into ddx of this log x equals to 1 by log x into 1 by log x. 1 by log x derivative 1 by x. Therefore, this equals to 1 by x into logarithm of x into log of x. This is the differentiations. ddx of log of x plus root over x square plus s square. If we take z, then this will be log of z, derivative log of z means 1 by z into differentiation of this x plus root over x square plus s square. We can also take this equals to t. Let t equal to x plus root over x square plus s square. Then this equals to ddx of log of t. This is the function of t, but here ddx, so we have to make ddt by chain rule. So do this ddt of log t into dt dx. Now derivative of log t with respect to t, 1 by t, and dt dx. Here we can find out dt dx. X means derivative of x is 1, and derivative of this root over fx. Derivative of root over fx means 1 by 2 root over x square plus s square into x, derivative of x square plus s square means 2x. This cancel. 1 plus x by root over x square plus s square, root over x square plus s square, LCM x square plus s square, root plus x. This is dt dx, root over x square plus s square plus x by root over x square plus s square. 1 by t means this x plus root over x square plus s square into this means x plus root over x square plus s square by root over x square plus s square. This will cancel. 1 by root over s square plus x square or x square plus s square. So this derivative of this root over x square plus s square derivative. Why this is? That means there is a function ddx of root over fx. Derivative of root x. Derivative of root x means 1 by 2 root x. So derivative of root fx 1 by 2 root fx with respect to fx. So derivative of fx, f dash x, this is the formula. ddx of root fx 1 by 2 root fx into f dash x. I have applied this formula. 1 by 2 root fx, fx means x square plus s square, and f dash x means derivative of x square plus s square. Derivative of x square plus s square means x square derivative 2x plus derivative of x is 0, that is 2x. 2x, 2 to cancel. This is the most important formula. ddx of root fx means 1 by 2 root fx into f dash x. Now y equal to tan inverse 3 square x minus x cube divided by a into s square minus 3x square. S square minus 3x square. This equals to tan inverse 3 square x minus x cube by a cube. We divide by a cube, numerator and denominator. We divide numerator and denominator by a cube. 3 square x minus x cube by a cube divided by a square minus 3x square by a cube. This equals to tan inverse 3 square x by a cube, part divide 3 square x by a cube. A square 2x will be cancelled, there will be 1a. 3 into x by a minus x cube by a cube means x by a whole cube divided by a 1a cancel, a square, it will be a square by a square means 1 minus 3 x square by a square, x by a whole square. This equals to 3 tan inverse x by a. Which formula? Inverse formula, very important formula. 3 tan inverse x equal to tan inverse 3x minus x cube by 1 minus 3x square. 3 tan inverse x, 3 tan inverse x equals to tan inverse 3x minus x cube by 1 minus 3x square. 1 minus 3x square. This formula. So we have found simplified value of y equal to 3 tan inverse x by a. So dy ddx of 3 tan inverse x by a, 3 is constant, it will come outside. 3 ddx of tan inverse x by a equal to 3 tan inverse x by a formula. Tan inverse x 1 by 1 plus x square. X means x by a whole square, but this is not x, it is x by a, so we have to take derivative of x by a also into ddx of x by a, ddx of x by a. Now this equals to 3 1 by 1 plus x square by a square into derivative of x by a means 1 by a constant. Derivative of x is 1. Derivative of x is 1. That is 1 by a. 1 by a. Take LCM, a square plus x square by a square. This will be here into 1 by a. Cancel 1. 3a by a square plus x square. This is ddx required derivative. This is dy dx. dy dx, ddx of y 3a by a square plus x square. It is we have said in lecture 1 that the derivative at a point represent the slope of the tangent at that point. If this is a curve denoting the function y equal to fx, then derivative at this point, this is this point is small c, this equals to c, origin x-axis, y-axis. Then the derivative at this point is denote the slope of the tangent at this point. This tangent at this point is if these tangents make an angle psi with the positive directions of x-axis, then slope of the tangent equal to tan psi. This equals to derivative ddx of y at the point x equal to c. So derivative represent tangent. So a function is differentiable or derivable at a point if a tangent can be drawn at that point. So a smooth curve, suppose the curve is like this, smooth curve, y equal to fx. For this curve, tangent can be drawn at any point. You can draw tangent here, you can draw tangent here, you can draw tangent here, tangent, then here also you can draw tangent, every point you can draw tangents to point. This is the differentiable functions. Differentiable function, because for these functions at every point the function is differentiable, that is every point tangent exists. Although many smooth curve also not differentiable. Suppose like this, this curve, this is a corner point or key point. Though therefore this function, if this point is c, that is this is c, then fx, and this function is fx is not differentiable at x equals to c. Like this curve, if this is the point of this point c, at this point the function is not differentiable because it is the corner point or king point. This point c, it is c, this point, here the function is not differentiable. So curve must be smooth and there should not be any corner point or king point. Sin x function, cos x functions is a smooth curve denoting they are differentiable everywhere. Now another example, it is y equal to x to the power x. Logarithm, here exponential function, but at the base and index, base is variable, index is also variable. To find out the derivative of x power x, we have to take log on both sides. Take log of x power x. Base is always e. Then log of y, this x will comes out by the property of logarithm log x. Now we have to differentiate both sides with respect to x, ddx of log y, ddx of x log x. Note that the function is of y, this function is of y, but differentiation with respect to x. So we have to make it differentiation with respect to y by chain rule. So to do this, we have to take this dy of log y into then dy dx by chain rule, and this is the product rule u v taking x ddx of log x. Now log x ddx of x. And now derivative of log y with respect to y, 1 by y dy dx equals to x. Derivative of log x means 1 by x plus log x. Derivative of x means 1, x cancel, dy dx equals to y, this y 1 plus log x. Y means x power x, 1 plus log x. This is derivative of x power x. X power x into 1 power log x. Okay. We can differentiate x power x in another way. ddx of x power x. This is the important formula in logarithms. M equals to e power log of m base e. Anything e power log of that thing base e. So we can write this ddx of e power log of x power x base e. Applying this formula, ddx of e power, this x will come here by the property of logarithm x log x base e. Now this is of the form e power fx. This is important formula, e power fx. Derivative of e power fx means e power fx into derivative of fx f dash x. So it will be e power fx x log x into ddx of x log x. Now e power x log x means e power x log x, e power x log x, e power x log x means this means this, that is x power x. And x log x, take x into ddx of log x plus log x into ddx of x. X power x, x into 1 by x plus log x into 1. X power x, 1 plus log x. ddx of x power log x. Okay, there are many problems, so today I have done up to this. Okay, thank you.